Hi friends, today we are going to discuss the very first chapter of Mathematics Grade 9, that is number system. Under this chapter we are going to discuss these different kind of concept one by one. There are different concepts: rational number, irrational number, what are real numbers, and what are the methods to find rational number or irrational number between rational numbers. Don't get confused, I'll tell you each and everything one by one. How to express decimal number in P upon Q form and all, represent real number line, laws of exponents, rationalizations. Most important concept among all is this rationalization. uh, this will as well, this concept and this last one is very important. So just come on the first topic, rational numbers. Let's pick that first, rational number. So the question is here, what are rational numbers? Rational numbers are those numbers which can be written in the form of P over Q, where Q should not be equal to 0. For example, if I take 3 over 5, after comparing this number 3 over 5 with P over Q, you can tell me what is Q over here? That is 5, and that is not equal to 0. Q, the denominator should not be equal to 0. So this 3 over 5 is a rational number. If I take the example of 1 over 2, that is also a rational number. If I take 5 over 0, this is not a rational number because Q is 0, which should not be 0. If I take the example of 3 only, is 3 a rational number? Yes, because 3 can be written as 3 over 1, where Q is what? Non-zero. Correct. If I take one more example, like 1.5, 1 decimal 5, is this a rational number? Yes. Why? Because 1.5 is nothing but 15 over 10. Means if we cancel this by 5, I will be getting 3 over 2. Yes, this is a rational number. Means this decimal expression is also a rational number. What about this number 2.5? Is this a rational number? Yes, this is also a rational number. Why? Because this can be further written in the form of P upon Q. Means this decimal number also rational number. So based on all these examples, there are two definitions of rational numbers. What are these? Let's see. Any number which can be written in the form of P over Q, where Q should not be equal to 0, and P and Q both are integer, obviously is called rational number. I give you many example. Let me take few more example. 3 over 5. This is a rational number because Q is not equal to 0. What is the second definition? A number which is terminating. Okay, it will be terminating. This I will discuss a little later. Let's see first this one, terminating. 0.6, is it rational number? Yes, because this is what? It's a terminating number. After 6 there is nothing coming. So 0.6 is terminating number, and every terminating number is called rational number. This is also rational number because this is written in the form of P over Q. What about this number? If I take the example of 1.34, this is also terminating number because after 4 there is nothing, means there is nothing repeating or nothing non-repeating. After 4 there is nothing. So this is also a rational number. What about this number, my dear? 1.3333 and move on. Same number is repeating, 333. In short, we can write this number as 3 bar. 3 bar. This sign means bar. It means 1.3333 and so on. So the meaning of this bar is that particular number is repeating. It is recurring. What's the meaning of recurring here? Repeating. Repeating. So any number which is non-terminating but repeating is also rational number. So can you see this 1.3 bar is a rational number? Yes, it is a rational number. Just for a time, just remember this, it is a rational number. I will prove it later why it is so. Because this number can be written in the form of P over Q, where Q is not equal to 0. That is a very important kind of question. We will be discussing this a little later. So I'll say in short, there are three definitions of rational number. First one, any number which can be written in the form of P over Q where Q is not equal to 0. Second definition is any number which is terminating. For example, 0.6, 1.5, 3.46256. That's it. This is also terminating number. After 6, there is nothing repeating. What about a non-terminating recurring number? If I put here 6666 and so on. Now, this number is called non-terminating. This number is nowhere terminating. It is still move on. 666 is coming. So, such kind of number is called non-terminating and repeating or recurring number. This number is also called rational number. Why it is called rational number and how can we convert such number in the form of P over Q, that we will learn little later. Let's move to the next concept, that is irrational. There are two definitions according to me of irrational number. The very first definition, any number which cannot be written in the form of P over Q is called irrational number. What are rational number? Number which can be written in this form and which are not irrational, which are not rational means irrational number. The number which can be written, which cannot be written in this form, they are called irrational number. What about this number, my dear students? If I take 1.34304, 3004, 3 times 4, 3 4 times 04, 3 times 5 times 04, and so on. This pattern is repeating. Okay, no pattern. Actually, this is unpredictable and it's still moving on. Now, what about this number? Is this non-terminating? Yes, this is non-terminating. Is it repeating number? Is something repeating again and again? No, nothing is repeating, my dear. This pattern is different from this. Next one is unpredictable. Next one, I can't say anything. It can be anything. Don't say, don't be sure like the next number will be 3, 6 times 0 and 4. No, I can't say anything about that. So what I want to tell you here, this kind of number is called non-terminating. This number is called non-terminating, non-recurring. Non-terminating, non-recurring number. And such kind of number are known as irrational number. So a number which is non-terminating and non-recurring is called irrational number. Let me take one more example. If I pick this example 5.2020202, is this a rational number? Yes, obviously it is a rational number. Why? Because after 2 there is nothing. After this digit it stops. This number stop here. There is nothing repeating. So this number is called terminating. That's why this is rational number, not irrational. This is a rational number. What about this number? 5.2020202020 and it is going on. Now see, I'm very specific about the pattern. This is 2020 is repeating, isn't it? And in short, it can be written as 5.20 bar because two digits are repeating. This number is called terminating but recurring number. That's why this is called rational number. But what about this example? 5.20 to double zero two, then 2 3 times 02. This is 2 4 times 02 and so on. This number is non-terminating, non-recurring. This is called irrational number. So there are two definitions of irrational number. First one, any number which cannot be put in the form of p over q, where q is not equal to 0. And the second number, any number which is non-terminating and non-recurring number. That is also called irrational number. Let's discuss the next concept. Obviously, this is real number, and we all know what are real numbers. Let me throw some light on this concept. Everyone know what are real natural numbers. Natural numbers are basically counting numbers. Counting number means which we use in counting, like 1, 2, 3, 4, and all. So natural numbers are these numbers. If we include 0 in all the counting numbers, means natural number, then this whole set, this whole group is called whole numbers. Further, this group is called integers. And the biggest group, including all these three, is called rational numbers. So what are rational numbers? That is already discussed with you all. And now, just tell me, my dear, can I say natural numbers are whole number? Yes, obviously, because all these numbers here, all these numbers are in this group. So I can say natural numbers are whole numbers, and all whole numbers are integers. Means I can say all natural numbers are integers, all whole numbers are integer, but I can't say all integers are whole number. Is it clear? And even I can say all these things, all these means integers, whole numbers, and natural number, they are also irrational numbers. I mean, this is the biggest set ever built. This rational number is what? A group in which we have integers, whole numbers, natural number, everything. And the definition is already clear. Can you say 0 is also a rational number? Yes, 0 is also a rational number. Why? Because 0 can be written in this form. P over Q, where Q should not be equal to 0. Yes, this is 1. Next one, irrational number, you know already what are irrational number. And if I combine these two group of numbers in one group, and then when, this one group is called real numbers. So what are real number? Real numbers are numbers including rational number and irrational numbers. That's the definition. Real numbers are those numbers which include rational and irrational numbers as well. Let me ask few questions here. Uh, the questions are, it's MCQ kind of question. Can I say all rational numbers are natural number? No, I can't say, because all rational numbers are not natural number. But converse is true. All natural numbers are rational numbers. Can we say natural numbers are irrational number? No. Can I say irrational numbers are natural number? No. There is no direct relation between irrational number and natural numbers. Now rest is up to you. How do you take all these set or group? Let me take the next concept, that is method to find rational numbers or irrational numbers between two rational numbers. So the first subtopic, I am gonna take this one. What is this? If we are given two rational numbers, for example, 1 and 5, how can you find rational numbers between two rational numbers? These are two rational numbers. How can you find rational number in between them? Yes, very easy. Even I can say 1.5, 1.2, 1.3, or 2, or comma 3, comma 4. All these are rational number between these two rational numbers. That's very simple. If I take 1.3 and 1.7, these two are rational numbers. How can you find a rational number in between these two? 1.31, 1.32, 1.33, 1.5, 1.7. There are many numbers in between these two numbers. What if I am given this number 1.4 bar? and this number is 1.7 bar. First tell me, are these two number rational number? Yes. I am to find rational number between two rational numbers. Because these two are rational numbers, now how can I find number between them? This is 1.44444 like this, and this is 1.7777 and all. Can you say 1.5? This is lying in between these two. Yes. 1.6 is in between these two. 1.51, 1.55, 1.62, 1.623. There are many numbers in between these two. Let me take few more example. If I am given 1.343 and here I am given 1.35. Now tell me, my dear, these two are given rational numbers, correct? These two are given rational numbers. I am to find three numbers in between these two. Three rational numbers in between these two. These two are rational and I am supposed to find three more rational numbers in between these two. So this is 3 4, my dear. This is 3 5. I can put 0 by my own because this 0 don't have any value after 5. Now this is 343. This is 350. So I can write 1.344, 1.345, 1.346, 1.347 and many more. Even I can write 1.3431, 1.332, 1.345. All these numbers are lying between these two rational numbers. So what was this concept? The concept was how to find rational numbers in between these two rational numbers. What was the concept? How to find a rational number in between two rational numbers. I'm not talking about this one yet. Okay, what about this question? If I'm given here 1.3 and here I am taking let's take here take 1.5 1 over 5 and here is 1 over 3. Just leave it for a while. Now the question is first tell me, are these two rational numbers? Are these two rational number? Yes. Now question is I am to find three more number in between these two. How many numbers? Three more numbers in between these two. There are many methods to find out these three numbers. The first method is obvious. This value is nothing but just calculate in mind. This value will be 0.2 here, zero point 0.2 here. Sorry, this value if I divide 1 by 3, I will get 0.3, something like that. So I will be writing 0.001, 0.202, 0.203. That's it. These three are rational number lying between these two. That's it. That's the question. We have one more method. What is that method? The question is how to find three rational numbers between these two rational numbers. Let's see how to do that. What were two numbers? 1 over 5. This was 1 over 3. Question is find three rational numbers between these two numbers. Now, how can we find that? The authentic method or the method we are using in your syllabus, in your grade, is this one. First, we have to make the denominator same. For that purpose, I'm gonna take the LCM. What is the LCM of 5 and 3? That is 15. Now, how can I make here 15? If I multiply this 5 by 3. Same here, if I am dividing by 3, I have to multiply. Same here, multiply this by 5 and multiply this by 5. That is 3 over 15 and here is 5 over 15. So what is the very first step to make the denominator same? This is 5, this is 3. So how did I make it same? 15, 15. I just multiply and divide by 3, 3 here, and divide and multiply by 5, 5. You can check, you can verify. If I simplify this, I will be getting the same value. If I simplify this, I will be getting the given value. Now this is 3, this is 5. I'm to find 3 rational numbers between these two. So how to find it? I can simplify in the form of, suppose this is 3.1, 3.2, 3.3, or even you can take here 4. Then divide by 15, divide by 15. That's it. These are the 4 number. You can pick any 3. There are many more numbers you can find in between these two. I hope this is clear for everyone. And there is one more way. If you don't want to take this way, if decimal form, this one is a little awkward, don't take this way. Take another way. 3 and 5. How many numbers you can easily find among them? Only one, that is 4. 4 over 15. But I am supposed to find 3 numbers. So let's take another way. Just make it a little bigger number. Suppose 30. How can you make it 30? If I multiply and divide by 2. If I multiply this by 2 and divide by 2, I will be getting 6 over 30. Here it will be 10 over 30. Again, both numbers are same, 30, 30. Now just find 3 number in between 6 and 10. So 7, 8, 9. Divide by 30. This is divided by 30. This is divided by 30. So these 3 number are 7 upon 30, 8 upon 30, and 9 upon 30 are my required answer. Let's pick the next concept. What is that? How to find irrational number between two rational number. Let's pick one example. Very simple example I'm gonna take. This is 1.5 and here is 1.6. I'm to find irrational number. Okay, one irrational number between these two. So that will be 1.5, 0, 1, 0, 0, 1, 3 times 0, 1, 4 times 0, 1, and so on. This is non-terminating, non-recurring number. That's why this is irrational number, and this number is existing in these two numbers. That's it. If it is asked to find more number, I can find more number. 1.502, 002, 3 times 02, 4 times 02, and so on. This number is also lying between these two given numbers. So it is up to the requirement. I can find as many number as I want. I guess this concept is clear. Let's move on to the next concept, that is how to express P over Q form in decimal form. That's very simple. If I take here 5 over 6, how to express this in decimal form? Simple, just divide 5 by 6. This is less than the divisor, so put decimal here. This will go by 8. Here is 2. Take 0 down. Then 2, 0. It start repeating. So this number is equal to 0.83333 and so on. So 83 bar. So I just convert this P upon Q form in the form of decimal form. For example, we have 1 over 5. So divide 1 by 5. This will go by 2. That's it. So 1 over 5 is nothing but 0.2, that is converted form, the decimal form. So what is this concept? How to convert? I'm just telling you the concepts only. The practice, the examples we will be taking later in the upcoming videos. So what is this concept? How to convert P over Q form in decimal form. But what is the converse? How to convert a decimal form in P over Q form? That is very important thing. Let's take what is that. I'm telling you the next concept, that is how to express a decimal form in P over Q form. This case, this concept is totally contrary to the this concept. Now suppose we are given 0.5. How to convert this decimal form in P over Q form? Because this decimal is having only one digit after this, so put 10 down. So I converted decimal form into P over Q form. Let's take this example, 0.52. That will be 52 over 100. So if you simplify this value, I will be getting 26 over 50. Further, it will be get cancelled by 2 only, so 13 over 25. What about this number, 0.24367? How to convert this into decimal form? Obviously there are 5 digit after decimal, so I will be dividing this number by 10,000. There are 5 digits, so 50 should be there, should be 1 lakh, I guess. Yeah, that's it. Now the next example is very important. Question is how to write this number in P over Q form, that is 0.3 bar. What's the question? How to express decimal form? This is decimal form. In which form I want to convert this question? P over Q form. This form I want. That's a little lengthier and important kind of question. Let me take this question first. Basically I'm going to take here different example of same kind, and I'll be solving everything on the same time. If I take here 0.25 bar, then I'm going to take here 0.125 bar. So how to convert this number in the form of P over Q? Same with these two. Simultaneously I'm going to take these three questions. First step is just assume x equal to 0.3 bar, and same will happen with the all the three questions. Assume x equal to the given question. Now the very first condition you have to aware is after decimal digits must start repeating. Check here, is it so? After decimal digits are repeating? Yes, after decimal digits are repeating. What about this example, 0.345? After decimal digits are not repeating because 3 is there now, 4 5 is repeating. So for this kind of question method is different. I'm taking first this case. The first condition is after decimal digit must start repeating, and they are repeating. You can see it, all digits are repeating after decimal. Second step, if one digit is repeating, because 3 is recurring number, because one digit is repeating, I will multiply both by 10. If two digits are repeating, I will multiply both sides by 100. If three digits are repeating, I will multiply both sides by 1000. This is 10x, and because this is 10, so one digit will come in front, 3.333 and so on. Same here, this is 100x. because this is 20 here, so two digits will move before this decimal, so 25.25 bar. Same here 3, so this is 1000, and here will be 125 bar. After this, assume the given part as 1, this is 2. Same in all, this is 1, this is 2 over here. Same, this is 1 and this is 2. Subtract 1 from second. Subtract 1 from second. Here as well. Left hand side from left hand side and right hand side from right hand side. So what is left hand side here? 10x minus x. What we have here? 3.3 bar minus 0.3 bar. This value is 9x. This value is nothing but 3 only. So x will be 3 over 9, means 1 over 3. But what was x? X was the given assumption. That was 0.3 bar equal to 1 over 3. So what I did here, my dear friends, I just convert 0.3 bar, which is non-terminating recurring number, in the form of p over q. Same here, 100x minus x. This x, right hand side from right hand side. What is right hand side here? 0.25 bar. Here will be 25 only, and here is 99x. So x is 25 over 99. What was x? The given question, 0.25. So the answer is this one. Same with this 1000x minus 1x. So I will be getting 999x equal to 125 point bar 125 minus this value. I will be getting 125. So the final answer is 125 over 999. Let me take one more example, because this concept is very important. I don't want to take any kind of risk to move to the further slide. What about this question? If this question come, convert or express 0.125 bar in p over q form, where q should not be equal to 0. Same thing, first I will assume x equal to 0.125 bar. Here only two digits are repeating, two fives are repeating, one is not repeating. And what was the condition I told you earlier? After decimal, digits must start repeating. Here one is not repeating, so what I have to do first? Bring this one first here before decimal, and because this one is only one digit, so I will multiply both by 10. This value become this value. And if I take one more example, like 0.125 bar, here 12 is not repeating, so first assume x equal to 12 bar. Now I want to take this 12 in front before this decimal, so I will multiply both by 100. If one digit is not repeating, multiply both by 10. If two digits are not repeating, multiply both by 100. Now after this is equation number 1, this is equation number 1. Now my dear, after here on I have to follow the same steps I have already taken. Now because two digits are repeating after decimal, so multiply both by 100. So if I multiply this by 100, that become 1000x. If I multiply this by 100, these two digits will move before this decimal, so that become 125.25 bar. Same here, only one digit is repeating after decimal, so I will be multiplying both by 10. That become 1000x because I multiply by 10, so one digit will move 125.5 bar. This is question number second. Now I have to follow the same steps. Subtract 1 from 2. Here subtract 1 from 2. So what is this value here? This is 1000x minus 10x. This value is 125.25 bar minus 1.25 bar. This is 990x and this value is 124. Here x is nothing but 24,990. Just simplify this. This will go by 2. This must be simplified, okay? Don't leave this as your answer. So 62 divided by 495. Further this will go by nothing, I guess. So leave as it is. What was x? The given question. 0.125 bar is equal to nothing but 62 divided by 495. Your answer. And my suggestion to everyone, just put your answer in a rectangle kind of shape. That will highlight your answer. That will help the examiner to know where is the answer. Same here. This is 1000x minus 1. This is 100x equal to 125.5 bar minus this value, that is 12.5 bar. This is 900x equal to 125.5 bar minus 12.5 bar. This value will be 1, 1 and 3. So the value of x is 113 divided by 900. This can't be simplified. So what was x here? The given assumption, the assumption 125 bar 113 divided by 900. I think the concept is clear so far. Now you can solve every kind of question. Let's move to the further slide. How to represent real number on number line. Now, what do you mean by real numbers here? A real number can be rational number as well as irrational numbers. So in this concept, we have further two sub-concepts. What is based on rational number and second is based on irrational numbers. How can we represent a rational number on number line? Let's take one example here. That's very simple. Question is represent 1.345 on number line. That's the question. First I'm going to discuss this concept, then I'll take this one. So first of all, just take one number line here. You have to use your scale. Here is 0, this is 1 here, 2. Distance should be same. It can be 1 centimeter, 1 inch, it's up to you, but the distance should be same. This is 3 here, same negative side, -1, -2, -3 and so on. This is called number line. Now where is this number lying? 1.3. This 1.3 is lying between 1 and 2. Again, draw a straight line here. I want to show these two numbers here. Suppose this is 1 here, 1. This 1 is taken here, 1. Now take 10 equal parts. 10, this is first one, same distance. 2, 3, 4, 5, 6, 7, 8, 9. You can extend it, and 10. If this is 1, what will be this value? This will be 1.1. This value will be 1.2. This is 1.3. This is 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and 2 here. This 1.3 is found here. I need 1.3. Now where is the next value? 1.34. This value 1.34 will be between 1.3 and 1.4. Now I will bring this 1.3 here and 1.4 over on the number line at the end. So again draw a line, straight line. This is 1.3 here. Again 10 equal parts. Parts should be equal always. First, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. This will be the last number 1.4. This value will come here and 1.3 will go there. This one. What will be this number, my dear? 1.31. Why? Because this is 30, isn't it? Nothing is after 3, so I can assume this is 0. This value is 1.31. This value will be 1.32. This value will be 1.33. This value will be 1.34. This value will be 1.35, 1.36, 1.37, 1.38, 1.39 and 1.4. I wanted to find this value and I found it. Now this value, the required value will be among these two values. So again the same thing here, just draw a line, bring this value over here. You can do the same way, 1.34. Again 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 1.35. This 1.3 will go at the end. This 1.3 will come here in the front. Now there is nothing coming after 4, so I just assume this is 0. So what will be this value? 1.341. This value. What will be this value? 1.342. This value will be 1.343. This value will be 1.344. This value will be 1.345. This value. Just highlight this. That is the required answer. So that is the method. How can you represent a rational number on number line? These kind of questions are in your syllabus and are pretty important here. Let me take one more example of the same kind. Question is, represent 2.38 on number line. So what's the method? First of all, take a straight line, show the number line. This is 0, this is 1, this is 2 over here, this is 3, this is 4 and so on. This is negative side, -1, -2, -3, -4 and so on. So this number 2 point something will be lying between 2 and 3. Pick 2 here and 3 at the end. How it's possible? Just draw a straight line. Assume this is 2 here. Take the equal lengths. This interval should be of equal length. This length equal to this length. And there are 10 equal parts. 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9 and 10. You can extend it. This is the last one. This will be definitely 3. So what is this value? 2.1. Why? Because this can be written as 2.0 means 2 only. This is 2.01. This is 2.2, 2.3, 2.4. I want 2.3. This is 2.4, 2.5, 2.6. It's better if you write everything. I'm not writing everything. It's better if you write everything. Now this value 2.38 will be lying where? In between these two values. Again same procedure. Just do a straight line. First pick the first value 2.3 here. Again 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9. and 10. This will be 2.4. What will be this value? 2.31, 2.32, 2.34, 2.35, 31, 32, 34, 35, 36, 37, 38, 39. Something went wrong. This is 2.31, this is 2.32, 2.33, 34, 35, 36, 37, 38. Yeah, this value is 2.38. This is 2.39 and this is 2.4. Just highlight your answer. That's your answer. That's it. I hope this rational number concept is clear for you all. Let's pick the next concept, that is irrational number. Now, how can we represent an irrational number on number line? In your syllabus, you will be getting such kind of question. Represent. I'm discussing this concept now. This one is done. So represent under root 2 on number line. On number line. Under root 2 is obviously irrational number, but how can I show this on number line? There is a very specific method, not even one method, there are many methods. Let me tell you the basic method which is given in your book. So what is this method? Just draw a line first of all. Somewhere write 0 in the middle, better. Take 1 unit. This is you can take this is 1 centimeter or 1 inch, that is depending upon you, your choice, but length should be same again. 1, this is 2, this is 3, and so on. Same here. This is -1, this is -2, this is -3 over here. What I need to find? Under root 2. I pick 1 unit anywhere. So best way is to pick this 1 unit. I am picking on this one, 0 to 1. Draw 90-degree angle over here from this side. You know how to use compass. So if I draw perpendicular on this value on point 1 here, again whatever length you assumed here, take the same length on this one, on the perpendicular. You can use compass, your scale, whatever the length is. This, it can be 1 centimeter or whatever, same length should be taken here. This is assume point O, this is point A, this is point B. Now join OB. This is 1 unit. This is also 1 unit. So what will be the length OB? That will be under root 2. Why so? Using Pythagoras theorem, we have OA as 1, AB as 1, OB I want to find. Pythagoras theorem, I think you all know. Let's see. Use that Pythagoras theorem. What Pythagoras theorems tell us? OB square is equal to OA square plus AB square. What is OA? OA is 1 square, plus AB again 1 square. That is nothing but 1 plus 1, 2. So OB squared is 2. So what will be OB? Under root 2. Means this length is under root 2. Now take your compass, put over on O the compass, and take pencil over here and draw an arc like this. This point, whatever it is, just give any name, whatever you want to take. Suppose I am going to take it is capital X, this point. So this point, 0x length. 0x length is what? 0x length is nothing but 0b. And what is that length? Under root 2. What I wanted to show? Under root 2 on number line. So this x point is under root 2 on number line. I hope this is clear. What if they ask you represent under root 3? Now they're asking under root 3 here. So till here everything is same. Now draw perpendicular on B. That's up to you. How do you draw it? This perpendicular. Now OAB length was 1 unit. Same length should be taken here. This is point C here. This is again 1 unit. Now join OC here. This is 1 unit. OC. Now OC length will be under root 3. OC length will be under root 3. Again your compass. Use your compass. Put on O. Open your compass till C and draw the arc. This arc is coming on point, suppose here Y. This point Y is nothing but under root 3. I hope this is clear. This is very important concept. We will be taking more examples in one of our videos. Let's move to the another slide. Laws of exponents. These are very important. Everyone must be familiar with all these laws. What are these laws? The first one, if base, this is called base, A is base here, and M and N are called exponents. A is base and M and N are called power or exponents. If bases are same, then their exponents get added if they're multiplied, and if there is product, these exponent get subtracted. Same like this. This is negative. If I take this whole thing down, that become positive. If it go up, that become negative. M upon N further can be written in this way or in this way. That's up to you. You have to memorize each and everything. And this further can be written like if we have AB power 5, this can be written as A5 and B power 5. Same here with A over B. These are the exponents, the basic laws. Everyone must be clear with all these. The last concept, I guess, is rationalization and rationalizing factor. Very important concept of the whole chapter. To know what is rationalization, I must know what is a rationalizing factor. What is rationalizing factor? Let me take one example. Suppose we have under root 2. If I multiply under root 2 by under root 2, what I will get? I guess 2. I use the law of exponent because this 2 become like this way. This is under root 4, that is nothing but 2 only. This was irrational number. I multiply this irrational number by this number. Irrational number, that is also irrational number. Now what is the result? That become rational. So these two factors, this is called rationalizing factor of this, and that is called rationalizing factor of this value. Let me take one more example. It will be a little more clear for you. If I take 2 positive root 5, and if I take one more value, 2 minus root 5, first tell me, my dear, is it a rational number? No, it is irrational number. This is also irrational number. If I multiply them, let's see what will happen. You know one identity, A positive B, A product with A minus B. So that will give me 2 square minus under root 5 square. This identity you will learn in second chapter. What is that identity? A plus B times A minus B, that is nothing but A square minus B square. This value is 4, this value is 5. So what we have? Minus 1. When the product of two radical expression This is called radical expression is rational. See, if I multiply this radical expression with this radical expression, what I'm getting one rational number. Then this factor is called rationalizing factor of this, or this rationalizing sorry this factor is called rationalizing factor of that. Means one is called rationalizing factor of the other. Same here. Root 2 is called rationalizing factor of this, and this is called that. Okay, let me take one more example. This is root 2, this is root 3. Both are radical expression, both are irrational number. But if I multiply them, will I get rational number? No. It means I can't say this is rationalizing factor of this value or this is rationalizing factor of that value. This result must be a rational number. If that is a rational number, then one of these two radical expression is called rationalizing factor of the other. Let me take one more example on this because this is very important concept. If I take uh, 2 minus root 3, 2 plus root 3. Can I say this is rationalizing factor of that? Yes, because if I multiply them together, I will be getting 2 square minus under root 3 square. How did I get that? The same identity I told you earlier. A minus b times a plus b is nothing but a squared minus b squared. This is 4 minus 3 means 1. That is a rational number. So how can I get if what will be the rationalizing factor of this? If this is a negative sign, change this by positive sign. That's it. If I ask you one question, what is the rationalizing factor of 5 minus 3? Because this is a negative sign, so this will be the rationalizing factor of this. Change the sign, that's it. I hope this is clear. Let me ask you one more thing. What will be the rationalizing factor of 7 minus under root 2? That will be 7 plus root 2. I change the sign, that's it. If this is positive, that must be negative to find the rationalizing factor. I guess this rationalizing factor concept is clear for everyone. Let's move to the next one. Now let me tell you what is rationalization. It's very important concept. There are many questions based on this concept and all are extremely important. We have irrational number in denominator. What is that denominator number? Root 2. Now if I multiply this by under root 2, I will be getting 2. So this is called rationalizing factor. Now I'm gonna multiply and divide by the same number. 1 over under root 2 become under root 2 over 2. It was irrational denominator. It was radical denominator. Now it become rational number. It was irrational number. Now denominator become rational number. This procedure is called rationalization. So what is rationalization? It is a procedure, it is a process under which we convert irrational denominator a rational denominator. Let's come on the definition. A process to make irrational denominator rational. Let me take one more example. If we have 1 over 2 plus under root 3. Again, okay, let me write somewhere here. 1 over 2 plus under root 3. Question is rationalize this. Rationalize the whole thing. Okay, I'm writing here. Rationalize this question. So how do we rationalize? I already told you what is rationalization. To convert irrational denominator rational denominator. So what is the method? The method is multiply this and divide by the same number by the rationalizing factor. And what is that? If this is positive, that will be negative. Let's see what happened. 1 time the whole thing, that is 2 negative under root 3. In the denominator we have 2 positive under root 3, 2 negative under root 3. So 2 minus under root 3, a plus b times a minus b, that become a square minus b square. 2 minus under root 3, this is 4 minus 3, means 2 minus under root 3 upon 1, or you can remove 1. The denominator was irrational number. Now it become rational number. That's it. So to such kind of question, we have to multiply or divide by which number? The rationalizing factor of the given denominator. If it is positive, that will be negative, and if this is negative, that will be positive. Let me take one more example so that it will be more clear for everyone. Question is rationalize 1 over 5 minus root 3. So what is the rationalizing factor of 5 minus root 3? That is 5 plus root 3. So I have to multiply and divide by 5 plus root 3. Same here, 5 plus root 3. Now simplify. 1 times 5 plus root 3, same value. Here we have 5 minus root 3, 5 plus root 3, just simplify. Numerator will be same. Here a minus b times a plus b, that will be a squared minus b squared. This got cancelled. 5 squared is 25. 25 minus 3, 22. This was irrational number. Now it become rational number in denominator. Still both are same. This is equal to this number. So this process is called rationalization. I hope all the concepts till now are clear, and these are the basics for this chapter. If you really want to solve each and every question of the chapter, you must know all these concepts.